simple form actually, the second law of thermodynamics. Here, these are three lines. Okay, this T shape. Okay, this T shape. If you remove this one, this part, this second law. Right? If you remove this part, this second law. So what are the three lines and why we have to remove this one, this one? I am again showing dashed lines here like this. So removing of this one or removing of this one, these two are known as second law of thermodynamics. So the first statement for this part is given by Kelvin Planck statement. Kelvin Planck statement. And this part is clausis statement. Clausis statement. Okay. Right? So second law of thermodynamics given by Kelvin Planck statement and second is clausis statement. So what is Kelvin Planck statement? These are the three lines. What are three lines? What are they? Everything we will discuss here. Three lines are there. If I remove this line, this Kelvin Planck statement. Here also three lines are there. If I remove this line, this clausis statement. Okay. Right? Now to go into detail for this statement, we have to know some basics here. So why we have to remove that line, what is that, and everything we'll discuss here. So first one is a Kelvin Planck statement. Okay. Kelvin Planck. And second is clausis. Right, clausis statement. Actually, these two statements of second law of thermodynamics are called as negative statements. These are called as negative statements. These are negative statements. Okay. These are called as negative statements. Why these are called as negative statements is the law defined by these two, either Kelvin or clausis, or it is a word is there in these two statements, that is impossible. Impossible means negative. It is impossible. Here also the clause statement is that it is impossible. So statement is not of the form, it is so that it is of the form, it is, statements are not like that. The statements are, it is impossible. So this impossible word is coming in these two statements, impossible. So which is impossible? So they are negative. So these two statements of second law are negative statements. Right? So what is impossible, everything we'll discuss here. Okay. So to know this actually second law of thermodynamics, first thing, the basic thing we have to know is reservoir. What is this reservoir? Reservoir. So reservoir is a infinite capacity. Definition is infinite capacity. What does it mean? What is infinite capacity? So infinite capacity is, suppose if you take, I will give some examples here for this reservoir. If you take air, atmosphere, so this infinite. This air can give infinite amount of oxygen, it is giving, and it is taking CO2, infinite amount of CO2. So it is not putting any restrictions, or it is not putting any limitation. So much capacity of which one, air I will give, so much capacity of oxygen I will give, so much capacity of CO2 only I will take. So that type of restrictions are not there in air, it is natural. So we can say that air is known as reservoir. Right? Next example is water. Right? If you take any river, anything there, so water, infinite capacity only. If you take out one bucket of water, means the capacity of water decreases? No. So it is infinite capacity only. Water is infinite capacity. So these are called reservoirs. So reservoirs means infinite capacity. Right? So to define this, which one? Second law of thermodynamics. This is important. Reservoir is important. Infinite capacity. Okay, right. And second thing is we have to know the heat engine. Heat engine. Here I am not giving full detail about heat engine. There just only important points only I am giving here, because we are dealing second law of thermodynamics, not heat engines here. So whatever the statement which we require for the second law, that only I am defining here for the heat engines, right? So heat engines. So to run these heat engines, we require two reservoirs. Already I told reservoir is infinite capacity, right? So this is one reservoir, this second reservoir, okay? We require two reservoirs to run this heat engine. Okay, this is a heat engine. To run this heat engine, we require two reservoirs, right? So from reservoir 1, heat is coming, that is known as Q1 heat, to this heat engine, right? So whenever the heat is coming, reservoir means it may be air. From the air, heat is coming to this heat engine, okay? And here, from the heat engine, because of this heat engine will do some work. So this is known as work here. And some part it is rejecting again to another reservoir, is again air only here. Q2 heat is again going to this reservoir only. So here 1 and 2 will act as reservoir, that is air only. Air is a reservoir, is also air is a reservoir here. So they may act, air may act as a reservoir because it is having infinite capacity, right? From the heat engine, whatever the pollution, pollutants or something which is coming from that heat engine, so it will take, that air will take, because it is having infinite capacity. How much it is giving, it will take. It will not stop. So that is the function of reservoir. Here also, heat coming, because the heat engine wants which one? Something to run the engine, means that reservoir has to give infinite capacity. It should not stop. So this reservoir. So a heat engine will work between two reservoirs. Reservoir means infinite capacity. What are the examples which I quoted, that is either air or water, those are known as reservoirs here. So heat engine is working between two reservoirs, right? So heat engine is taking this one Q1 heat and it is rejecting, not rejecting, it is doing some work here, and it is which one? Rejecting Q2 heat here, right? Now again here first law of thermodynamics is applicable here. Why? Because law of conservation of energy. What is law of conservation of energy? So the Q1 it is given to the engine. It is of two forms now. Q1 given, it is of two forms, W and Q2, W plus Q2. So Q1 equal to W plus Q2 is again your law of conservation of energy, one form to another form. Here Q1 is one form of the energy is converted to another form. Suppose 10 joules is converted into 6 plus 4 or 7 plus something. So Q1 is converted to another form, that is work plus Q2. So that is the law of conservation of energy. It is nothing but again our first law of thermodynamics, right? So heat engine here, first law of thermodynamics application is there. Okay, right. So this is which one? Regarding heat engine. So again I am summarizing here, to function this heat engine we require two reservoirs and this heat engine will do work. So actually for doing work in engine, the main important point is two reservoirs should be there and work is there. So that is the which one important statement here for the heat engine to define the second law of thermodynamics, right? And the third basic thing which we require is for heat pump or refrigerator. The third basic thing we require to define second law of thermodynamics, heat pump. Okay. So this is a heat pump, okay, or refrigerator. You can say refrigerator also, right here. So again, to work this either heat pump or refrigerator, again we require two reservoirs, 1 and 2. These are reservoirs here. Okay. So from this reservoir, it is the reverse of heat engine. So it will take heat here, right? So here Q1 is coming rejected to this one, which one? Reservoir here, right? So to do this, we have to supply work here. To do To work this one, we have to supply work. This is another form. This is a which are reverse of heat engine here. Okay. Again here also your law of conservation is working here. Q2 plus W equal to Q1. Right? Q2 plus W equal to Q1. So this again law of conservation of energy. Right? So depending on this heat engine and heat pump, the figures which I draw, this second law of thermodynamics is defined here. Again, heat pump and refrigerator again works on two reservoirs, either heat engine or heat pump. Two reservoirs should be there and work is there. So these are the which are common in heat engine or heat pump or refrigerator. Two reservoirs and work is common. So what is this second law of thermodynamics here? Now we can define, because we know reservoirs and we know heat engine, heat pump and refrigerator. Okay. Now in the starting introduction part I showed that lines, three lines. No, now you can understand the lines here, right? So these are the three lines. Okay. So these are the three lines, right? Now you can take this as reservoir, this as reservoir. Okay. Reservoir 1, reservoir 2. Okay. And here Q1 is coming here, Q2 coming here. This is the work done. This is known as heat engine. Okay. Heat engine, right? Here Q2 is coming here. Work has to be done to run this heat pump or refrigerator, right? So here Q1 is coming in. So the lines which I have shown is of this form. So what is second law of thermodynamics is, I told we have to remove this part. If you remove this part and if you remove this part, so this is known as Kelvin Planck statement. Kelvin Planck statement of second law of thermodynamics. Very simple only. Kelvin Planck. This is clausis statement. That's all. So what is statement here? Very simple. Because these two are negative statements. So what is statement here? It is impossible. It is impossible. This word is there for both the statements. So what is statement of second law? It is impossible to run heat engine on a single reservoir. That is the statement here. For single reservoir, heat engine working is impossible, right? Or we can say in another form also. So part of that heat supplied to heat engine, some of the part should be rejected here. So when here some of the part is not rejected because another reservoir is not there. In another form, the statement is, it is impossible for the heat engine to convert total heat to work, because no reservoir means our 10 joules means 10 joules coming means that is impossible, 100% efficient. So that is impossible for the heat engine. Some should be rejected here, Q2 to the reservoir, then only that is possible. Impossible thing is if it is not there, it is impossible to convert total Q2, total Q1 to W is impossible. That is our Kelvin Planck statement. So writing this as statement is, it is impossible to work the heat engine from the single reservoir. Okay, or it is impossible to convert total heat to total work. Q1 equal to W is impossible. So that is a negative statement. Impossible thing is telling. This is second law of thermodynamics. Here if you take this heat pump or refrigerator, this is work here. Q2 is coming here. So Q2 to Q1 means heat is flowing from lower temperature to higher temperature is impossible without the external agency. If this line is not there, so Q2 is flowing to Q1. Is it possible from lower to higher? It is impossible. By nature it is impossible. So that is clausis statement. Right? So it is impossible to convert all the, which one? From the hotter body to from the colder body to a hotter body. To conversion of Q2 to Q1 is impossible. So to convert Q2 to Q1 from lower to higher, some work has to be given from the external agency. So that is our which one? Clausis statement. So the statement is, heat cannot flow from lower to which one? Higher temperature without any external agency. Without this external agency, it is impossible. That is our clausis statement. So these two statements are our second law of thermodynamics. Okay. So here I am summarizing statements here. It is impossible. It is impossible, right, to work heat engine from single reservoir. Okay, from single reservoir is impossible. Another form is, it is impossible to convert total work to total heat supplied. That is impossible. This is a statement of Kelvin. What is clausis statement? It is impossible to flow heat from colder to hotter without the blue. Without external agency, it is impossible. So these are the statements of which one? Second law of thermodynamics. Okay. Thank you.